Yes, class. Am I audible to all?
Yes, ma'am.
Yeah, ma'am.
All right. Okay. Please open the cameras, all of you. This was one of the assignments which I said I'll be discussing in today's class. So, see, from impulse.
Ma'am,
Yes.
I had a doubt in the third question of this.
What question?
Like,
I'm on the first question right now. Okay. A batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. Mass of the ball is given as 0.15 kg. You have to determine the impulse imparted to the ball. So class, this kind of same question we have done in the class where a ball is coming and it is bouncing back. So this is exactly the same thing. Mass is also given speed. It's just that one speed you have to take as positive, other speed will be negative. Okay, now coming to the second question. Cricket ball of mass 150 gram moving with a velocity 15 meter per second is brought to rest by a player in 0.05 seconds. This is the initial speed, this is the final speed, and this is the time. Okay. This is a cricket ball of this much mass. Mass is also given. It says calculate the impulse and the average force exerted. So see, you have initial mass and initial velocity, and this is the final mass and final velocity. So you will get change in momentum. That will give you the impulse. You divide it by this time. That will give you the force. Now coming to third question. Yes, I think Maha, you were having a doubt in the third one. See, Maha, did you share this assignment? Impulse?
no.
Why?
Because like I did the assignment from my laptop, but then I submit my assignments to my phone, right? So the app that I was supposed to send it to, it wasn't working.
Okay. So today try it, at least whatever you have done.
Okay.
Okay. See, this is a rubber ball of mass 50 gram falls from a height of 1 meter and rebounds to a height of 0.5 meter. So whenever you have balls and you are throwing, you're dropping a ball. So what will happen? Ball will touch the ground and it will rebound. But because of loss of heat, loss of energy, the exact height is not regained by the body. Reason is that because of the loss of momentum. If a ball has been thrown, then when it is rising, it doesn't rise to the same height because there's a certain loss of energy. Now, why energy loss is there, that you'll better understand in the chapter work, energy, and power when we'll talk about the conversions of energies and how energies are put. But right now, just understand that energy is lost, energy is dissipated. That's why you're not able to regain its original. Now it says this is the mass falls from a height of 1 meter. This is a ball. This is falling from a height of 1 meter. When it is falling down, it is completely under the influence of gravity. That is acceleration due to gravity. Yes. So here the acceleration is due to the gravity. Initial velocity, did it give us? A rubber ball of mass falls from a height. No, it means initial velocity here is 0. And we have to find the impulse. Average force time should be given for average force. 0.1 seconds. See, now for this part, we know the distance is given. Acceleration is acceleration due to gravity. Let's take 10 here. Though it's not stated here, you have to take it as 9.8 meter per second square only because it's not stated. But right now I'll be taking this as 10 meter per second square. So see, U is there, S is there, A is there, and if I calculate V from here, I just need one equation that will give me the velocities formula. So I'll at least have the first velocity. Now this velocity will be under root 2VH because U is already 0. So V square minus U square is equal to 2VH in this case. That will give me this velocity. So it will be what? 20 root 20. This velocity will be almost under root 20 because height is 1 meter. Now see, look at the second case. It rebounds to a height of 0.5 meter. Now from here to some point here, it is rebounding to which height? Height here has just changed as 0.5 meters. Okay. Now here is it stopping? Is it stopping? Not. We don't know. We don't know anything about this ball right now. It can happen that it is again rebounding back to 0.25 meters. We don't know that. So what do we know from here? We know the initial speed right now, because whatever was the final speed here will become the initial speed when the ball is falling high. So let's say we got here root 20. So root 20 becomes our initial speed, s becomes zero point 0.5, and acceleration is the same acceleration due to gravity. From here we'll get this final velocity. This will, let's say this is v1, this will be v2. So you have the momentums. You can calculate the momentums now. How? Mass is there, 50 gram, converted into kg, 0.05 kg, multiplied to this velocity. Now, this velocity is directed downwards. See, when the ball was coming, this was directed downwards. This velocity will be directed downwards. So whatever you're choosing as pen down, you have to be careful with the sign convention, because this final velocity is directed upwards. This is leading the ball go up. Then again, it will come down, up, down, up, down. This is how a ball stops, right? And why does it stop? That we'll see in today's class if time is there. Friction. That is due to friction. If I take this as positive, I'll have to take this as negative. Okay. Same equation we are going to use for this as well. Here you will have u square. When you will put u square, that will become 20. Same calculations, you will get v2. So m plus mv1, and here minus mv2. Again, you will have mv1 minus of minus mv2. You will just add them. That will give you the impulse divided by the time. That will give you the average force. Tell me, class, is this clear?
Yeah.
Yeah, ma'am.
Okay.
Ma'am.
This says, fourth one says momentum is 5 kg meter per second, strikes a wall with an angle of 45. Okay, it's the same question we did. It's like this is striking, and this angle that is given to us is 45 degree. The angle that is given to us is 45 degree. What do we do in such case? In such a case, we resolve the velocities. See, this is the angle given 45. So what we do, we have to resolve our velocity. If it is hitting the wall, let's say, this is how we can resolve it. Whenever you have any vector, what did we study when we were studying the resolution of vectors? Main vector is there, other vectors, vectorial components will be associated with it. So right now here, this is how we'll resolve. Now, since this angle is given, this angle will also be 45 degree. This will give us V cos 45 degree. This will give us V sine 45 degree. Similarly, this velocity is directed like this. So when you resolve, its component, one component will be like this, one component will be like this, because you only have to focus on the rectangular components. Rectangular components mean they are perpendicular. Vx and Vy, they'll be perpendicular. If this is 45, so this will be 45. Corresponding angles, here it was alternate angles. Here, these are corresponding angles. So if this is 45, this becomes V cos 45, this becomes V sine 45. Now see, this appears at a first glance that V cos 45, V cos 45 will cancel each other. And these V sine 45, V sine 45, they'll be added because they are directed along the same direction. But it won't happen. When you will put the sign convention, you will see, because both of them have the same sign, they get cancelled. And this becomes similar to this. Minus of minus, so they'll get added. So this is how you will solve the fourth question as well as the fifth question. In the fifth question, just the difference is the actual angle given to us is 30 degree. So here, instead of all these 45 that I have taken, you have to take 30 degree. Okay. Is there anything else in this? What is the direction of the force of the wall? Direction of the force of the wall due to each ball. Two identical billiard balls strike a rigid wall with the same speed but at different angles. Okay, here this is the initial case.
Ma'am, and then the ratio as well. Can you explain that also?
Yes, let me just see this question. The figure is of this question only. Okay, so this says two balls, they are striking a rigid wall with the same speed but at different angles. Okay, this is one ball, this is second ball. Okay, so here you have to take two cases. Look, this says when you have two cases, here no angle is formed. This ball, this is the first ball, two identical balls are striking a mirror. These are not two different cases. In the sense, they are two different cases, but they are talking the two balls that are being mentioned here. These are those two balls. Let's assume that this is one ball, this is another ball. So this question's impulse will be similar to this question, second question, which we studied, MV, the ball that was hitting you directly. And this second part would be similar to the fourth one, where we'll resolve and then calculate mu cos 45 degree, mu sine 45 degree. You know how to solve the questions individually. You can calculate the change in momentum for the first one. You can calculate the change in momentum in the second one. Using resolution for the second one and directly. One you are going to take as plus u, then it is getting repelled. Are you getting it? These are the same cases, just written in two different manners. The question number, second, whatever we did, what is the first case? And the fourth one, which we did at an angle, this is the second case. Now see, it says that and get reflected without any loss of speed. So I just want to tell you that view will be the same. Otherwise, it could have been u1, it could have been u2. It says u are the same. Initial velocities, whatever velocity with which the ball is hitting is the same. What is the direction of the force of the wall due to each ball? See, direction of the force of the wall means your Newton's third law. Okay, when if the ball is exerting a force, let's say here the ball is exerting a force towards the right. So ball will exert a force of exactly the same magnitude towards the left on the ball. So this is basically, this question is based on the Newton's law. Okay, Nabila. So this is based on the Newton's third law. So similarly here also, when the first ball is hitting, when at the first place the ball is hitting it here like this. So what's the velocity? We saw the components. Okay. So here also the force will be like this, directed at 30 degree from the horizontal. This will be the direction of force. If this is the velocity, force will be directed that side. This is how the momentum of the ball is coming. The force will be directed like this on the ball. So you can simply say 30 degree from the horizontal, or you take out the components, fx cos 30 degree, f sine 30 degree. But I don't think so that's needed because you don't want to solve anything. You're just telling, no, what's the direction? This is the, I think this is more than helpful for the direction. 30 degree from the horizontal. That will tell the direction because you don't have to calculate anything in the first part. Second says magnitude of impulses, so that you calculate delta P1 by delta P2. Okay, now fifth question is clear, Aisha?
Yeah, ma'am. Thank you. So
Okay.
in the first one, we just have to give the direction with the reference of the angle.
In the second, for the second one, yes, because this the velocity is also at a different angle. That's why.
Okay.
Okay. Question 6 says a position time graph is given, mass is given, and it says between two consecutive impulses received by the particle. What is the time between two consecutive impulses received by the particle? So time in all of them, can you see it's just 2 seconds? So here you don't have to solve. This is just 2 seconds gap. It says what's the magnitude of impulse? Now see, we have to calculate here the magnitude of impulse and mass is given. So class, if we calculate the velocity, what kind of graph is this position time graph? Have we not studied position time graph? We've already studied this in motion in a straight line. So okay, tell me how is which quantity will give us the velocity, slope or area here? Slope of the graph or area? Yes, Aisha, slope. Because I told you when two things are getting divided, you always take the slope. If I take the area, that will give me acceleration, right? So here the slope will give me the velocity. X by t will give me the speed. Now I know any two consecutive impulses I can take. Look, you start from 0, you move to 2. This is already given as 2. 2 divided by 2. This will give us the first speed. That is 1 centimeter per second. Okay, one thing you have to be careful. This is given in centimeters. So whatever velocities you get, you then have to convert it into meter per second. Okay, because the centimeter won't help. This is also in kg. This is already in seconds. So you have to convert this. 1 centimeter is there. Like this is 2 centimeters. So you use it 0.02 meter like this. So this will also become 0.02 0.01 centimeter per second, like that. Similarly, for this part automatically will come out negative. The slope is decreasing. So same thing, same question. From here you calculate V1, from here you calculate V2. Mass is given, you will get the impulses. That's it. For the impulse. For the first part, it's already given from the graph. This is a question of NCRT. Back exercise NCRT question. This one, fifth one. Yes, I think the first one also. Yes, these are questions from your NCRT. Okay, one more assignment was there. I think Sanidhi, you have shared this assignment today, no? Conservation one.
Yes,
You've given.
ma'am.
No.
There are two
See,
more we need to discuss.
yes, Aisha.
There are two more that we need to discuss. The last weeks.
After impulse, this one was conservation of momentum. Which
Yeah,
is which one,
there is
Aisha?
1 minute now. There is conservation of momentum and then the pulley.
This pulley one I'm not discussing because students haven't shared it. This at least I've received some, and this also I
Okay.
haven't checked Sanidhi yours, so that's why I'm discussing this. Let's see if I get the assignments by tomorrow. So I'll discuss that. See, class, I think this won't be tough for you. This whole topic we
Mama
discussed
send the
already.
pulley one, right?
Yes, Maha. Yours pulley one I have received. See, this is a 30. Maha, I think I've reshared it to you on that day only, no? You
I
must have
haven't
received the
checked.
check one. Yeah, it must be checked of yours. Sanidhi's is remaining. Sanidhi, because you shared it today itself. No, Sanidhi, I'll share it. See, we discussed this 30 kg. This one is done in the class itself. Okay, even this one is discussed in the class itself. Car of mass 1000 kg traveling with this. This is also done. Yes, Aisha.
I had a doubt in the fifth one.
Fifth one. Yes, I'm coming to. Let me see the third one. Third one we haven't done in the class. Third and fifth I'm
I have a
discussing.
doubt in the third one.
Third and fifth I'm discussing. Okay. 1, 2, and 3, 1, 2, and 4 are already discussed in the class. So that you can refer to the notes. Third and fifth I'm discussing. See, third says a hunter has a machine gun that can fire 50 grams of bullet with speed 150 meter per second. So mass of the bullets are given and the speed of the bullet is given. It says a 60 kg tiger springs at him with a velocity. So mass of tiger is given and velocity of the tiger is given. It says how many bullets must the hunter fire into the tiger in order to stop him to attack back. See, these kinds of questions they have a very big meaning in the languages, but it's just that it is saying number of bullets are missing. Tiger, how many tigers are there? Tiger is one only. This is clear from the question. But we don't know how many bullets have been shot on him, right? So we'll just say n is the number of bullets. So momentum will be conserved anyways. Number of bullets that are being used into the momentum means mass of bullet into the velocity of the bullet is equal to number, or let's say number of bullets, and here number of the tigers into mass of tiger, velocity of tiger. Now, for the number of tiger, you know it's 1. The rest of the data is also provided. Only this is missing that you can calculate using this equation. Just see as if number of tigers and number of bullets are there. You're just multiplying it to the number. Now, since you know tiger is only one here, it could have been different. They can make the question different. They can say 2 tigers are there. Then you have to write 2 here. So use this equation. Right now, you just have to get the bullets because tiger is only one. Okay. Third clear? Okay, fifth question. Let's come to the fifth question. This says a disk of mass 10 kg, 10 grams. 10 grams is floating horizontally between 10 marbles per second against it from below. All right, so disk is there and 10 marbles. So number of marbles we have, mass of the disk we have, and there are few marbles like this. Marbles are present on which this disk is rotating. And there are 10 marbles. Okay, marbles number is also mentioned to us. If the mass of each marble is 5 grams, so mass of marble is also mentioned. Calculate the velocity with which the marbles are striking the disc. Assume that the marbles strike the disc normally and rebound downward with the same speed. Okay. So instead of the mirror, the wall that we were taking here. Yeah. The way these were, we were taking these walls, we were taking. Right now, it is saying a disc is there. Okay. And a disc is present like this, and it is flowing horizontally. Okay, how is it able to move? When the marble strikes it, it rotates. When the marble strikes it, it rotates. So mass of this disc is also given 10 grams. Okay. So 10 number of marbles are there. Mass of the marble is given. We have to calculate the velocity with which the marbles are striking the disc. So see, that velocity of the marble is missing. Let's say I'm writing for the mass of the marble. Let's say velocity of the marble here, and mass of the disc is there 10. Velocity of the disc hasn't been mentioned. A disc of mass 10 grams just kept floating horizontally by throwing. See here, angular velocity of the disc is missing because disc will rotate, no? Just wait, let me just check this question. Meanwhile, just write this. Let me just confirm. I think they just by mistake didn't type the angular velocity. How will it be solved? Angular velocity will be there of this, and there's a relation v is equal to omega r. Using that, you have the velocity of the disk. Okay, so this is a part of your circular motion that we will be doing in the laws of motion only. After completing friction, this topic is there. So then using the same equation, you will solve this. Number of disk is one only, the way the tiger was one in the previous question. Same mass velocity here, velocity is missing. Let me just check, please wait. Yes, class. There's just one line which is missing here. Velocity, angular velocity of the marble is not given. The line is that here it has said, no, assume the marble strikes the disc normally and rebounds downwards with the same speed, and the force exerted is due to the weight of the disc. And it then again says take the acceleration due to gravity as 9.8 meter per second square. Okay, so that is just missing here. That's why it wasn't given. It said, see, what is meant by this? Let me explain. You see, it says whatever is the force, weight exerted by the disc is being balanced per second by the 10 marbles. So basically, weight means mg. Okay. So from here, you will calculate the force. Force, that is the weight, because this is given in the question that weight is being balanced. Okay, this is a line missing in this. There's a typing error. So how is it being balanced? 10 grams are there, 10 into 10 to the power minus 3 into this 9.8. Because in the question it has said to take 9.8 meter per second squared. Okay, so that will give you the force. Now, using the discs concept, using the marbles concept, you will calculate the impulse. Yes. Now we know force is equal to change in impulse by change in momentum by time. So momentum can be calculated number of the marbles into mass of the marbles into velocity. This velocity we'll just say something as v. Let's say this is as this. Let's take this as v. Okay, only one velocity is needed because that is only what we need to calculate. So look, in marbles into mass of each marble is 5 into 10 to the power minus 3 into some velocity which we don't know, divided by the time. Now see, it said per second means in 1 second. So divided by 1. What is this? What have I written? The momentum divided by the time. What is this equal to? The force 10 into 10 to the power minus 3 into 9.8. So this will be cancelled. 10 will be cancelled. So we will be 5 by 9.8 meter per second. So if it is 10, this is 0.5, this is 9.8. So a little less than 0.4 something the velocity will come. Now did you get it? This part?
Can you explain the question again?
I'll explain. See, a disc is there. Just imagine this is a disc, okay? And there are many marbles present. Question says that disc is rotated when the marble strikes on it. That's why, because of the force, it is being rotated like this when the 10 marbles strike it. Now the question has one more part, one additional part, that the force of the disc is the weight of the disc is being balanced by the marbles per second. Okay, and you have to take the acceleration due to gravity as 9.8. So if its weight is being balanced by the marbles, it means its force. So we'll calculate mg using F is equal to mg. We'll calculate what's the force that is being exerted by the disc on all those 10 marbles. So that force will be this. Now, what is the formula of force in terms of momentum? F is equal to P by T, momentum by time, rate of change of momentum. That was Newton's second law. Now, momentum and time and force, these are three things here. Okay, let's understand the velocity of the marble, the momentum of the marble. If I want you to calculate the momentum of the marble, how will you calculate? Mass into velocity. For one marble, you will say it is mass into velocity. So what's the mass of a marble? 5 into 10 to the power minus 3. So I've written the mass of the marble. Okay. Now this is what? This is the velocity of the marble. So this is its momentum for one marble. Now the question says there are 10 such marbles. So if for one, won't you multiply it for 10 to get the momentum of all the 10 marbles? So this is the total momentum. And number of marbles into mass into velocity. That's the momentum. So we have momentum with us, but we don't know velocity. So we have just put it as V because that's what we have to calculate. It is asking you to calculate the same velocity of the marbles with which it is striking so that this is being maintained. The weight is being maintained. That's it. That's what I was saying. They are striking it in such a manner that it is not moving. Its weight is being maintained. Because of the gravitational force, its weight is being maintained. So this is the momentum. Now time has already been given as per second. So we have taken the time as 1 second. Force using mg we have calculated. So force we know. From here the variable velocity can be calculated if I equate F with P by T. Yes, Aisha, now clear?
Yeah, mom, got it. Thank you.
Okay. So this will be around 0.4 something. Just check and write down this question. And in your words, write about this also, that the weight is being balanced by the 10 marbles. Okay. And this is mentioned in the question. Weight is being balanced by the 10 marbles. Please copy down this one for question 5th. Just let me know once done, class.
I'm done.
Yeah, mom, done.
Okay. Now see, one pulley assignment is there, and then today I'll give the free body diagram. Did I give in the last class? Free body diagram homework is not given, no? That we'll discuss today. We could only discuss 2 questions from the class. Class, your weekly test was also held, and I hope all of you have received the answer sheets. Those students who have joined right now, all of you gave the test. Yes, so just do one thing. Instead of discussing all the questions, there are 8 questions. So the number is also few. Just text me in the chat box. What are your doubts? Because most of the questions, most of you were able to answer. So
Mom, can
I
you
think
please discuss the last question?
8th, Sanity. Okay, 8th.
Yes.
I'll discuss. Other than 8th, what is the doubt? Or do
Ma'am,
one thing. Yes, ma'am.
in the fourth question, I just couldn't do it in the calculations. As you saw, you put a question mark over there because I just couldn't do it.
Okay, in the 4th question. All
Yeah.
right. Apart from it, others also tell. Please just check your answer sheets. Meanwhile, let me just discuss one question from here. Then I'll discuss the weekly test also. Otherwise, we'll not be able to complete this. Here, 1 or 2 questions are left. Let us just complete this. Then I'll come to the weekly test today itself. Before starting with friction, I'll come to here. So class, in the last class, just pay attention and meanwhile, just let me know the doubt questions also. 4th and 8th I have received. 4th and 8th I'll discuss.
Third
8th,
one.
third one. 4th, 3rd, 4th and 8th. Third one. Okay. All right. C class. In the last class, we started with the equilibrium of the concurrent forces. Means different forces are acting in different direction. You have to balance all the forces. That's what we studied. And few questions we did. Pulley mass system we started. And this one question was what we did. See, it's a question directly from NCRT. Only I've taken the picture and uploaded it. It's 4.12 example of NCRT. I hope you all are doing the in-text questions also, these examples also of NCRT, because these also have very good questions. It says a wooden block of mass figure is this. This is the figure that is. It is a wooden block of mass 2 kg rests on a soft horizontal floor. This is it. Okay, the A case. Then it says when an iron cylinder of mass 25 kg, this one, this is the iron rod, is placed on the top of the block, the floor yields steadily and the block and the cylinder go down together with an acceleration of 0.1 meter per second square. It says what is the action of the block on the floor before and after the floor yields. Before and after means this only. See, when will the floor not yield? When will the floor not break? When this iron rod isn't put. When the iron rod is put, the weight becomes so heavy that the floor yields off. So before means this. This is what is meant by before, and this is what is meant by after. So once this is put, then the floor breaks off. Before means this is the case. So that's what the question says. Mass is given of both of the things. Mass, see, the block has a very less mass, 2 kgs only. So whatever floor it is taking a soft horizontal floor. Soft horizontal floor will not have the capacity to wear much weight. So 2 kg is fine for the block, for the floor. So if I say 2 kg, this means in the A part, see, whether the diagram is given to you or not, I'll repeat this, free body diagrams have to be drawn by you. Okay, whether it's the pulley problems or any question, draw the block separately, whatever body it's given. It's not necessary it's a block always. You can get a car, a ball, anything. Just take it separately and write all the forces, draw all the forces. And even in few questions, I think somebody's paper also I wrote this, that your answers were absolutely right, but you didn't make any figure. So you have to show how are you getting the forces or how is the force balancing. Most of the questions that we solved were based on the figure only, upwards forces balancing the downward force. Yes, so forces have to be balanced. That has to be shown by you. And free body diagram is a topic in your book. This question is taken from that topic only. Okay. And V is 10 meter per second square here. Okay. So this block has a mass of 2 kg, and this is put on a floor. So when we are talking about this block, let's draw the forces that are acting on it. If this is put on the floor, according to all of you, what are the forces that are acting?
mg and n.
Mg and n. Yes, direction. Direction. Tell me the direction.
N towards up and mg towards down.
N upwards means, see, wherever the body is put, the direction of the normal reaction will be away from the body, okay, and perpendicular to the surface. So surface is this is one normal reaction, one mg. Now this is not accelerating because right now it was at rest. The floor, this soft horizontal floor, could bear it. So this is that what is this is all that we have. This is what is the action of the block on the floor. Action of the block on the floor. Basically, we have to calculate the normal reaction. The floor is exerting a force of let's see what will be the normal reaction. Normal reaction will be equal to mg. G, it is saying to take it as 10. So this becomes 2 into 10, that is equal to 20 Newton. Now look, what is the meaning of this 20 Newton class? It's a very easy part, but just understand its meaning. It means, let's say I have a block. Okay, this is the floor and this is the block that is put on it. Now, whatever is this able to exert a force on the floor, the floor is exerting the same force on it, the reaction forces. That is why the question says identify the action reaction pairs also. So the ground is exerting a force of 20 Newton above on it. And this is also exerting a force of 20 Newton downwards as a reaction force. So this is how these are making the action reaction pairs. Okay, so when it says action reaction pair, the ground is exerting the force of 20 Newton on the block is exerting a force of 20 Newton vertically downwards. Okay, is this clear? First part, let me
Yeah,
write
ma'am.
down the statement. See this one. Block exerts a gravitational force downwards on the floor, and equal and opposite force is exerted by the floor on the block. That's the A part. Clear?
Yeah, ma'am.
Okay. Let's come to the B part. It says after the floor yields. After the floor yields means after the floor breaks off. The floor breaks basically when this cylinder is put on the block. The floor cannot bear it and it just breaks off. So it means now this is an accelerating system. So for you, what are the masses? When we're talking about the B part, there's a block which is present, and on the block rod that is present. This has a weight of 25 kg. This has a weight of 2 kg. So you will not be talking about them separately because right now the entire system is moving down. Okay, so for us, what all forces are acting? Now tell me what all forces are acting for this one. Yes, what all forces are acting here?
The same normal force in mg
Force.
plus the.
Same forces will act. See, because you
Oh,
have to identify your system. See, same forces will be acting. Your system is block plus the cylinder. That is your system. Okay. Your system, all of the forces depend on the system. If my system was just 25 kg block, right now, what is the system? Because both of them are moving together downwards. So I don't have, if I say in an elevator, a person is standing and the mass of the man is 70 kg, mass of the elevator is 300 kg. So will I consider 370 kg, or I'll take the mass of person separately and the elevator separately? We take them together? Yes, because that becomes our system. I think I discussed the system surrounding
Yeah.
universe, internal forces and all. Yeah, this is based on this. So see, both of them are moving downwards together. So what's the total weight? Total weight means
27
total
kg.
force. 27 kg, exactly. See, now the force on them is 27 kg. So 25 kg and this 2 kg, they are making 27 kg. So see, you can just write a big block with the weight of 27 kg. Got it? On which the one of the reaction forces is normal reaction, one of the forces is the downward ground. But when we are talking about the normal reaction of the floor, that will be different class. Why? Can anyone tell me? Why will that be different? Yes, ma. You were answering something?
No, can you repeat?
I am saying in the first part, this is the total masses. Here the total mass is 25 plus 2, which is equal to 27 kg. Yes? Now
Yeah.
see here when I am calculating the normal reaction for this system. Let's say this is moving with 0.1 meter per second acceleration. No? This is moving downwards with acceleration of 0.1 meter per second square. Okay, now see, here the entire 25 kg block and 2 kg block, they are moving downwards with 0.1 meter per second square. First tell me, what is the system here? What is your system exactly?
The whole block. The two
Both the,
blocks.
yes, both the blocks. So remember one thing, here the system means the block plus the cylinder. That's why we are saying not that the weight of the block or the force of the block, this is because of 25 plus 2. Okay. If I say what's the force of the gravity, mg, if I calculate here the value of mg, won't it be Fg will be mg, which is acting downwards if I draw it, wait. If I say downwards, mg is acting. So here what will be the force? Mg will be equal to 27 into 10 equal to
So
270 Newton. Do you all agree till here? Okay, till here the question is clear to all of you? Okay, I was saying mg we have calculated here. The way normal reaction was equal to mg, so this question could be just solved in 1 second. I am saying, can you just tell me? It says no action reaction is. Do you think now in this case the floor will be exerting the same 270 Newton on the blocks or not? This is my question.
it will, right? Because every action has an equal and opposite.
Every action, okay, but this is not an action. This is the force of gravity. See, apply the second law, Newton's second law. Then you will be able to get the third law. Action of floor will be there. That is correct, ma. Floor will be exerting an action. It says no action reaction pairs. So your this answer is right that the floor will be exerting a force because every action has an equal and opposite reaction. So there is an action by the system on the floor due to which it breaks off. And the floor must have also exerted a certain force on it. But see, now the floor has broken off. Now the system is accelerating. So exactly same the way we see a normal reaction, above force is equal to the downward force, normal reaction is equal to mg. This won't be here. Yes. Now what we'll have here, if I say there is certain force acting between them. If I say, let's say some normal reaction is acting here, or let me make it here only. Let's say some normal reaction, this n and this n is different class. This n is for the first part. This normal reaction is for the second part. Okay. Now this normal reaction is there. Class, we have studied the Newton's second law's application when acceleration is there. Can anyone tell me what will be the equation that will be formed? Because this time normal reaction is not equal to your mg. This is what I'm trying to tell you. Got it? Normal reaction is not equal to mg because the entire system is accelerating. When can you say normal reaction is equal to mg? Here there wasn't any acceleration. The upward forces that were acting were balancing the downward forces. Here your system is accelerating. So you won't have the exact same value of normal reaction. You cannot say normal reaction is 270 Newton, right? So can anyone tell me what will be the equation form? Use the Newton's second law. In elevator man problem, we did this so much. Direction of acceleration, we take something as positive. Okay, what is Newton's second law? F net is equal to ma.
MA.
So what is F net here?
The force.
The
The force being exerted.
yes, yeah, that is it, F net. But what should I write here?
Now you're asking for substitution.
I'm asking what should be my F net. Till here, all of you have understood that we have to use F net is equal to ma. Now, how will I solve this? What is the net force here?
mg minus n is equal to ma.
Exactly. C class mg minus n. We did this so many times. Why were you all not able to tell this? When the elevator man problem we did, remember I told you acceleration's direction is always taken as positive. If acceleration is acting downwards, your mg, see here, how do I calculate the net force? Two forces are acting. Normal reaction is acting or mg is acting. If two forces are only acting, then one can be n minus mg or it can be mg minus n. Now, how do we decide is it n minus mg or mg minus n? We look at the direction of acceleration. If we see acceleration is directed downwards, our downward forces will be negative. If I say acceleration is directed upwards, so all the upward forces will be positive. System is moving downwards. It means obviously this was the greater one. That's why the system went down, right? If this normal reaction was so strong, it wouldn't have let the floor break off. Acceleration will always, you don't have to apply so much of brain that what will happen, then what can lead to what. No, you see acceleration is there, this direction will be positive. Now that's it. So if net forces, two forces are acting, what is my net force? This is simply mg minus normal reaction is equal to ma, the same equation that we have studied. Okay, now what is mg? Mg is equal to 270 minus normal reaction we have to calculate. Mass is 27. Yes, of both of them. Into acceleration is zero point 0.1. From here, I'll get the normal reaction. See, it is not equal to 270 this time. Reason is that the entire system is accelerating. Right now, the entire system is accelerating. Upward forces are not balancing the downward forces. We'll get a different value. So what will it be? 270 minus n. This is equal to 2.7. So this will be a very lesser value. This will be 270 minus 2.7. So this will be equal to 267 something. 267.8. No, 267.3. So this will be 267.3. Yes. See, so this is a little lesser than the normal reaction, what we were getting initially. See, if this acceleration wasn't present, our normal reaction would have been 370. And plus, when the system accelerates, you need to apply this equation. Okay, now did you understand this question?
Yeah.
Others also? Please write it. Class, please just copy this. Meanwhile, I'm just coming in 2 to 3 minutes. I have to pray and come. Please wait. Class done?
Yes, ma'am.
Others also? Nabila Maha?
Yeah.
Okay. Let's discuss one more question. See, here the rest of the things I have not written. The question had that a block is kept on a table which has a string attached and passing over it smoothly, and a mass, another mass is attached, which has the free end. So this is the figure, and M1 is 10 kg, M2 is 5 kg. It says you have to calculate the tension and acceleration. But it is for the tension, you have to calculate it during the motion and when the body stops. Pay attention, class. Just understand how to draw the free body diagrams. This question you will not find it difficult. It's just that you have to mark all the forces, write the equation. See, was the calculation part here difficult? Calculation wasn't difficult here. In any of the questions that we have seen here or the previous questions, the calculation part will not be difficult. Calculation will be very easy and get your answer till the final step. It's just that writing of the equations is important. Okay, I shall take the screenshot then. To make the free body diagrams, class, and then write the equations of all of it separately. Done?
The B part. Yeah,
Okay.
this is done now. Thank you, ma'am.
All right. See, let's say this is the first block. Now see, when I say the free body diagram, we have to draw all the forces that are acting onto it. Okay. During the motion and when the body stops, these are two separate things. Let us just see the question first here. This is M1. M1 has the mass 10 kg. Now what I'm doing, I'm drawing all the forces, all the possible forces that are acting on this. See, upwards a normal reaction will be occurring. As mentioned in the question also, a capital R is occurring here. Okay. Downwards M1G is occurring. But this is of no use to you because the body is not moving along y-axis. So this will be n will be equal to m1g then. Okay, you know this is being balanced. But now where is the motion occurring? The body is sliding towards the right side. So you have to focus more on the x-axis rather than the y. Y-axis is balanced. But see, when you are drawing the free body diagrams, draw all the forces that are acting. A tension will be acting here because there's a string and tension acts always away from the body. Now, just tell me one thing. Is there any force acting on this block that you think should be there and I haven't mentioned?
M2.
An opposite force to T.
What, Aisha?
An opposite force to T.
Which force is that? You cannot construct forces. Maha, what you were saying? M2.
Yeah.
M2 will be for the second block. And
But then
M1,
the second block is the one that is pulling the first block.
yes, that is right. Because of which it is moving. But there is no force exerted because they are connected by the string. Whatever forces are occurring, no, they are due to the tension. Okay, so no
Okay.
other forces occurring. Okay. So here, if I make the equation net, we know what's the equation. Net force is equal to mass into acceleration. That's what we studied. Now here, this is being balanced. Tension, there is no other force to counter it. So here the force is the tension force is equal to mass into acceleration. Now this T is equal to 10A. Now we cannot solve it further. We don't know neither the acceleration nor the tension. So what we'll do, let's come to the second block. This one, which is being hung. This is, what's the mass? 5 kg. 5 kg moving downward with an acceleration. This was moving here with an acceleration. This was moving downwards. And upwards, a tension force is acting. And downwards, 50 will act. 5 into 10 mg. Yes, mg will be equal to 50. Now tell me the equation for this one.
Take 10 equals 50 over here.
What?
I think so.
Make the equation.
50 minus T.
What, Aisha?
50 minus T is equal to ms.
Yes, very good. See, net force 50 minus T or T minus 50. Acceleration downwards, so 50 minus tension is equal to mass is 5 into acceleration. Okay, so from here, first part says acceleration. So let us calculate the acceleration only. If I put the value of T here, it will be 50 minus 10A is equal to 5A. Is it? This is fine. So from here, will I be able to get the acceleration or not? We'll be able to get the acceleration from this one at least.
Yeah.
Yeah.
Okay. So 50 is equal to 10A will go on this side. So that becomes 15A. So acceleration will become 50 by 15. So this is 3, this is 10. This will be 3.33 something, 3.33 bar meter per second square. This is the acceleration. Now acceleration we have got. It says, look at the second part, tension during motion. Tension during motion means this tension only. What is this tension equal to? 10A, that is equal to 10 into 3.33, that is equal to 33.3 Newton. So this is the answer for the first part. This is the answer of the second part. Is this clear till here?
Yes,
Yeah.
Okay. If this is clear, can you tell me what will be the change for the third part? Because we only have one tension, T, which we have calculated. So what is the difference? How will I calculate the third part? Where do you think will the change be there? Yes, Nabila, your answer, you haven't answered anything. What do you think? Tension when the body stop? Do you think there will be any change in this? The equations that we have drawn, everything that we have written? Because tension we have calculated 33.3.
Mom, will there be no change since it's the same root?
There won't be any change. Means this is also 33.3. You're saying this?
Yeah, I'm not sure though.
Okay. Anyone else? When the body stop, why will there be any acceleration? Won't the acceleration be zero?
Yeah.
So when the body stop, the acceleration is zero. These equations will not be framed. If I say acceleration is zero, tension is equal to 50. The tension will balance this. Got it? Why we were taking acceleration? Why this equation was made? Because the body was accelerating. That's what I tried to tell you in this last question also. Here the body was at rest, acceleration zero. We said normal reaction is equal to mg. Then the body started to move. So we had to make this equation. Similarly here also, when the body is moving, so you have to make this equation 50 minus 10 is equal to 5a. But when the body stops, means acceleration is zero. In the third case, your tension will be just balancing your M to G. Above force will balance the downward force, that is 50 Newton. Now did you get it? In both the questions we use the same concept. Please write it quickly. Is it done?
Yes, ma'am.
Okay, let me discuss the weekly test then because it will be left then. Let us discuss it tomorrow. From this, one question is left. That is a lengthy question, but that needs active participation of yours after you practice today's class. That last question will have a lot of topic that we have done from this topic. And then we'll discuss pseudo force and friction force tomorrow. Okay. So tomorrow, try to give the assignments, fully assignments, those who have not given. Yes. Third question, someone said yes. Third, fourth, and eighth. I'm discussing these three. If there is any other doubt apart from this, then tell me tomorrow because we have very less minute, 10 minutes of it. The third question says a bullet is fired at an angle of 15 degree with the horizontal and hits the ground 6 kilometers away. Okay, angle of projection is 15 degree. Is it possible to hit a target 10 kilometers away by adjusting the angle of projection? If I want to find out, will I be able to hit anything at an angle of at a certain distance? I should know what's the basic distance if I am throwing something at an angle of 15 degree from the ground. Okay, if I know I'm throwing it at an angle at this angle and for this particular distance, so I should know what's the exact complete range, all the possible ranges that are possible. So see, range of formula, range of motion formula, u square sine 2 theta by v. This is the formula. Now see, here range is given to you that when this angle is there, it hits it at 6 kilometer. From here, can we at least get the value of u, initial velocity? I think Aisha, it was your doubt. Yes, Aisha.
Yeah.
Okay. Range is given that at this angle, this is the range of motion that is being covered. So I don't remember the value, what it is, but 6,000 will be the range. Sine 2 theta will make it sine 30 degree, u square. So it will be a big value. But what I remember is when you will put it in the value, final answer was 12 kilometers. Okay. Now from
And
here,
for
I
the
should,
V, you're asking, right?
yeah, I'm asking for the u. Yes. What was it?
I did not find the V. I just substituted in the maximum
Okay,
range.
directly you've put it in the
Yeah,
maximum. Okay.
like V
So,
square
and
by
also,
G equals 12, and just
okay.
substitute over there.
That's also correct. See, Aisha, whatever when you will solve this u square sine 30 degree divided by g, this is equal to 6,000. This is clear, Aisha?
Yeah, ma'am.
Okay. Then it says, is it possible to hit a target 10 kilometers away by adjusting the angle of the projection, assuming the initial speed to be the same? It means you are seeing what is the maximum range of motion that is possible from your end. If your maximum range of motion possible is 9 kilometers, so this, because it is 6 kilometer, it will be more than 6 kilometer. So if you know your maximum possible range of motion is 9 kilometers, so it won't hit. If it is more than 10, if it is crossing this 10, so then you'll be able to hit it. So when you calculate the maximum range, if you remember, for the maximum range, it was u square divided by g. So from here, whatever is the value you get, you will finally get this when you solve this. From here, you get u square by g, you put it here. So the value that you will get will be, I think 12 kilometer is the value that you all were getting, right?
Yeah.
Yeah. So see, 12 kilometer is the range. This is just saying to hit at 10 kilometers. So it will be able to hit. Okay, Aisha, got it?
Yeah, ma'am. Thank you.
Okay. Then fourth question, someone said, no. A person observes a bird on a tree 39.6 meters high and at a distance of 59.2 meter. With what velocity the person should throw an arrow at an angle of 45 degrees so that it may hit the bird? We did a similar question in the assignments. Maha, if you remember the horizontal motion, you can use the trajectories equation. V is equal to
Yeah,
u
I
sine.
know that. See, I did it, but then I got lost in the calculations.
Calculation error is there. I think
Yeah.
in this, yes, the calculations were tricky. You have to finally substitute the formula of time here. Whatever formula of time you're getting from the next equation, that you have to put. So did you put that?
See, I found time, and then like
What is your time, Maha?
time I got is as 59.2 root 2 by u.
Okay, that's fine. That's correct. Then yes. Then
And then substituted in the formula of like s equals ut plus half and everything.
okay, you
That's where
couldn't
I got
just solve
lost.
it. You couldn't just solve it till the last step. Okay, so that's just because of the calculation that you have written. Yes, because I remember you couldn't write it completely. What I'll do, because your steps are already right, so there is nothing to explain in here. I'll just share the written part with you, how to solve it.
Okay.
Because I remember to solve this question easily, you should multiply it with some 0.70 square on both the sides, and you'll get the answer very easily for the fourth question. So that I'll just write. I'll have to write it and then share. Okay, and only 5 minutes are left right now, so that solving part I'll share it separately on WhatsApp with you, Ma. Okay, because your equations were correct. 7, okay, 8th class, 8th one, there is, this is a motion on an inclined plane. This is a topic that will come in the laws of motion chapter. There we'll talk a lot of uh, inclined plane problems, but here the range of motion for a projectile motion has a formula. It has a derivation also, but we won't be discussing the derivation, because the derivation, for the derivation, you need to know some things about the laws of motion and inclined plane. We have a separate topic, motion on an inclined plane. So why angles and all are there, that you will be able to understand. Okay. But right now I'm just telling you basics. It is saying a shell is fired from a gun from the bottom of a hill along its slope. So from the bottom of the hill it is being fired. The slope of the hill is 30 degree, means this is equal to 30 degree. Okay. And the angle of the barrel to the horizontal beta is 60 degree. The initial velocity is given. Find the distance from the gun to the point at which the shell falls. So basically, you have to get the range of motion for an inclined plane. The formula of the range of motion for an inclined plane is very simple. I'll just tell you the formula for the time being. Remember the formula. You can do the see. It's not something out of your syllabus. This is a part of your syllabus. It's just that in the final exams, these questions come mixed with the laws of motion and all. The formula is 2u square. Now, sine, I'll tell you what is theta. Cos alpha divided by g cos square alpha. Now, alpha is this. Okay. Your beta is here. Theta is basically beta minus alpha. So here, alpha is also 30 degree. Beta 60 minus 30 will be 30 degree. You have u as 21. You put the value in one line, you'll get the range of motion. Okay. Now, I'll just give you a little hint on how we actually solve this question. Like, how do we derive this formula? See, downwards the weight acts of the body. Okay. Here, downwards the weight acts. Whenever you are resolving anything along the plane or across the plane, for this, you need to find this angle. Now look, this angle is 90 degree. So this becomes 90 minus whatever is this theta. I'll take this as alpha. 90 minus alpha. So if this is 90 minus alpha, this total is again 90. So this again becomes alpha. Using this, now your g is acting like this, so you have to resolve it. This is g cos alpha, this becomes g sine alpha. Now again you make the equations of range of motion the way we derived it, but using these components cos alpha and sine alpha. And since this angle total is given as this is given as 60 degree to the horizontal total one, you subtract to check what is the actual angle of projection. This is saying something total is 60 degree. So you subtract 30 degree and check what is actually the angle of projection. So don't worry about this derivation thing. That will be very unclear right now because we haven't done inclined plane. For inclined plane, you need to know the linear planes, right? For the explain when you actually understand. So remember this formula. Through this, you will get the range of motion in one line. Okay, apply this. You will get down. Okay, note down this. Okay, this will be clear when we'll do the inclined plane. Why this is alpha and all. Okay, please write it.